In this video, I'd be talking about constructors. Constructors cannot be marked as static or final or abstract. Constructors they cannot be marked static because of obvious reasons. Constructors are meant for instances, not for the whole class. They cannot be marked final or abstract because constructors are not inherited, so it doesn't make sense to have final or abstract modifiers to constructors, because final or abstract are used only in the context of inheritance. Right, so let's take a look at this example in which this is the super object. B extends object, C1 extends B, C2 extends C1, and I have a static main. So I do Java C2, right? I'm running the main method using Java C2. So what happens is, well, the interpreter looks at this, and instead of, okay, so it says C2 extend C1, okay, so, and then it goes, okay, let me load C1 first, and then it looks at this, and then it says, well, C1 extends B, so let me load P first. So it looks at this, and then, well, P extends object, so let me load object first. So it goes on this. Now, so the object class is the first class to be loaded, right? Now, because the object is loaded first, the static blocks in the object class would be executed initially, right? And then P would be loaded, and then the static blocks of P would be executed, right? And then C1 would be loaded, and the static blocks of C1 are executed, and then finally C2 would be loaded, and the static blocks on C2 are executed. So if I were to have a static block right here, then it would be the last one to be executed, because you could sort of imagine this as a call stack in which C2 is trying to extend C1. Now C1 would be tried. The JVM would try to load C1, and then it looks at this, and then, right, so it pushes sort of C1 to the stack, so C2 into the stack, and then C1 into the stack, and then P into the stack, and then object into the not into the stack, but it looks at this, executes this, and then unwinds the stack, and then executes the static blocks of P, and then C1, and then finally C2, right? Now, if you do something like this, well, okay, so because you're executing the main method, this line of code would be executed, right? And then if you would have a constructor box in C2 in this class, right? A constructor box is nothing but a set of constructors, right? And then imagine if you have one constructor calling another one. Now, because this is the default one here, say this is the default one trying to call the one with trying to call a constructor which is parameterized, and then this in turn calls another one, right? And then this in turn calls another one, and which well, okay, just before that, let's take a look at this. Right, so the first line of a constructor by default is a call to super. But if you choose to provide it yourself, then you could provide something like this, or this with arguments, or super with arguments, right? Now, if you notice, it's only the static blocks are initialized by the time you made this call, right? So these are the bunch of actions performed before even beginning the first line of execution. Before even beginning the first line of execution, these are the bunch of initializations of the static members performed. So by the time you're in the constructor, only the static members are ready, but not the instance members, right? The instance members are done within the constructors. But this being the first line of constructor, only the static members are ready by the time you can provide arguments. So as a result, these arguments should either be constants or can only be static members, as these are the only ones available by this time, right? Now, okay, so the first line of a constructor, no matter what it is, even if it's by default or even if you provide it, it's a call to another constructor within the same class, or it's a class to or it's a call to the superclass constructor within the parent class, right? So this indicates the constructor calls, the possible constructor calls within the same class, but at some point in time there should be a call to super, right? Because you cannot keep on calling the constructors again and again, because there would be one constructor without any explicit um, or without any explicit this or this with args, right? You either need, there is either a default one or you would provide super with arg, right? So that would make a call to the C1's constructor box. The same rules apply here, and then you make a call to P's constructor box, and then you make a call to well, because object is P's parent, you make a call to objects class. Right, and then objects constructor is executed, and immediately after that the objects initialization blocks would be executed, right? And then because P made a call to objects constructor, the controller would return back to P, and then P's constructor would be executed, and after that P initialization blocks would be executed. Now, right, the same applies for C1. C1's constructor is executed, and C1's initialization blocks are executed, and C2's constructor is executed, and C2's initialization blocks are executed. And finally the control returns to this line here. Okay, so right, so let's quickly take a look at an example. Right, so this is the example. Okay, I have a class B, and A extends B, and class understand call flow extends A, and then I have a static initialization block in understand call flow, which is invoking a new A object, right? Okay, now let's see what happens. Now JVM looks at this. Well, I'd be doing Java understand call flow, whatever, understand call flow, and then JVM tries to load understand call flow and looks that call flow is extending A, so it tries to load A, and then looks that A extends B, and then it loads B, and then B implicitly extends object. So suppose it would be loading object first and initializing and performing OB. Right, and performing OBJ's static block first, and then comes in, and then so after performing this, it would do B static blocks. So that's the reason why you're getting this, just getting the flow, right? So this is this here, first line of output, and then A static blocks are executed, and then these two are executed in order. So as a result, you could see that these two lines are printed, this one and this one. Now C's, so this one is executed, which could be seen right here, right there, that's the one. Now after that, because I'm trying to create a new object of A, right, and then it would look at the default constructor of A, right, which is this one here. Now because there is an implicit call to super, it would call B's default constructor, and then which in turn calls the object's constructor, and then the object initialization blocks are executed, and then B's initialization blocks are executed since there are none in B, and then A's initialization blocks are executed. So it says init block of A, which is that line there, and then finally this constructor is executed, and then it says in constructor A, and then the controller returns back to this point, indicating the object is created. So what should be understood here is that if you don't have an explicit call, if you don't in your constructors, if you don't explicitly say this, or this, the compiler would add a call to super. So this is the default piece of code added by your compiler to the constructors if you don't provide either one of these three here. Right. Okay, so the static blocks are executed in order, so this way downwards, and then I should avoid forward referencing, because the compiler would squawk in terms of in case of forward referencing, because if I have B, which is an instance member, and if I try to initialize B within a block which precedes B, then there is an error, right? And so in this case with static, I have a static member here, I'm trying to initialize it here, it's an error, right? And if I were to have a whole bunch of static members or static blocks, say static and so on, these would be executed in order. So it's the case with instance or initialization blocks. If I were to have them right here, so this one would be executed before this one, so they're executed in order, and the order matters. Right. Okay, let's take okay, so a default constructor provided by the compiler looks like this. It has no arguments. It has the same access modifier as its class, and it includes a call to super call with no arguments. So if this were to be my class, right, and the default constructor provided by the compiler has the same access modifier as that of the class, right, and the same name of the class, right, so with no arguments, and the first line would be a call to super. So that's my default constructor. So imagine you have something like this, right? You have the parent class has no default constructor because it has explicitly provided a constructor with an argument. So the compiler doesn't provide the default constructor anymore. Now if you were to have just this without this, right, the compiler would say this is okay. So if you were to just have the class declaration without the constructor, the compiler provides this. Now according to the compiler, it's making a call to the super, right? That's the condition of the default constructor. So if you look at this here, it makes a call to super. So that's what the compiler is doing in the default constructor here. But there is no constructor in the parent class, which is the animal class. There's no constructor that takes no arguments. There's no default constructor, right? So in such cases, the compiler would complain saying, well, your superclass doesn't have any default constructor. So what you would have to do is you'd have to write your own constructor explicitly, and then make an explicit call to super, and then provide a name so that it would invoke this constructor there.